We get to warm up this cold room here. I'm going to interrupt all the capture the flag stuff and maybe show you some other capture the flag like stuff as well. So my background, like I said, is in development through Maven and Java. I work at Sonatype, and at Sonatype we have a unique view into at least the Java ecosystem just through some flukes of history. You can see here we've been working on Maven for a long time. Most importantly, we're also the caretakers and the stewards of the Maven Central Repository, which is the largest repository of Java open source out there. It's not just for Maven. Pretty much any Java-based tool is pulling stuff from here. And so this gives us a really unique view into what's actually happening as it relates to application security and open source usage. So this first thing we're going to talk about here is I think something most people are aware of, but higher ups in the organization may not be aware of. So it's sometimes interesting to explore this. But you can see here, this is Don Duet, co-head of technology from Gartner, talks about how critical applications are all using open source, right? This is key. I think everybody here knows this. Why are we doing that, right? Why are we using so much open source? Well, it allows us to stand on the shoulders of the people that came before us and in theory, gain massive increases in productivity. We don't have to sit down and write our own UI presentation layer anymore. We don't have to do the database. We don't have to do the networking. Experts in their industries can do that, and we can use them usually for free. And so the evidence of that, of us increasingly consuming this is quite stark, right? So way back when we started Sonatype, the amount of stuff being downloaded was minuscule back then. It was fun paying those bills. But nowadays, you can see here all the way on the right, we did 52 billion component downloads last year. And if you compare that to NPM, for example, because their units are smaller, they tend to be more like downloading classes versus whole jar files, 59 billion, right? And so the trends continue to grow, which is showing that as companies become more and more agile and start to do things faster and faster, they're increasingly using open source. And it's not showing any signs of slowing down. In fact, if we look at across the ecosystems, how many new projects are out there, we've got over 1,000 new projects released every day, 10,000 new versions of those projects every single day, on average being released 14 times a year, right? And these numbers, you can see, it's a little gray down in the bottom there, are from, this is just PyPy, NuGet, Java, and NPM, right? Those are the big four these days. And so, this transcends human analysis, the ability to be able to keep track of what's actually going on, especially inside of organizations that are downloading hundreds of thousands of different components every single day. Traditional approaches to managing that aren't really working. But what's also interesting is with containerization, we're seeing the same types of trends going on. And so now we're talking about basically the operating system, or what we used to consider virtual machines. Those are basically components in and of themselves as well, right? And so all of these containers are being downloaded, and they're coming from third-party sources. Who knows how they were set up, how they were created. So the end result of this increased consuming of these components is that the modern application is now comprised of 80 to 90% of third-party components. Not all of them are open source, but I want to draw this line in the sand and say, there's some code that your developers are creating and writing, and usually these days that's 10 to 20% of the business logic that's wiring together big things like Spring or struts, logging frameworks, Angular, all those kinds of things. So when you think of what's actually happening in terms of the code that you're distributing and you're actually running, it's quite literally the iceberg scenario. What you guys are focusing on a lot of times is just the part that's visible, and there's so much more below the scenes. The same is true for containers, right? And this gets a little bit more scary because now you're building on top of not only maybe some logging framework that has one or two committers on it, but if you're not careful, you might be pulling down an actually operating system distribution, and who knows who installed it and how it was actually configured and how secure it is and those types of things. And so this is sort of the state of what's going on. Again, we're using more and more of it because in theory it allows us to innovate faster, gives us faster productivity gains, but we have to pay attention to it because not all of these things are created equally, right? Not all the components that are out there are are good. So anybody in here willing to admit that they're still using struts? Yes? No? No? I set you up on that one. Usually I ask before and people are like, yeah, I'm using it. It's good. I think this audience here is generally, hopefully, more tapped into what's going on out there. But the defect rate, we could see this from the downloads in Central, for Java components anyway, is 1 in 18. The trend is getting better. I think people are starting to pay attention to this. We've been talking about this for a long time. But still, if you're an organization pulling down hundreds of thousands of components, that 18% or 1 in 8 is still, 1 in 18 is still a lot of components that are finding their way into your applications. And that's just Java. Here's JavaScript, right? So these statistics are showing that at the time they were pulled down and put into the application, they were known to be vulnerable, right? Which means people are just ignoring the fact that there are these responsible disclosures out there. There's other talks going on about those kinds of things. And so as security practitioners and developers, we can try to do the right thing and follow these disclosures. At the end of the day, the end users are not really paying attention. These statistics show that, right? This is another one of my favorite examples. A lot of times we talk to people and they say, yeah, we're downloading these vulnerable components or we're including them in our application, but we're not using the affected functionality. Well, Bouncy Castle is basically a clean room implementation of crypto algorithms for Java. Everybody uses it because it's more portable than the JVM in terms of the algorithms that it supports. And yet there was a level 10 completely exploitable vulnerability disclosed in 2007 that would allow you to watch the traffic and then reverse engineer the keys. So you could collect traffic and then eventually figure out the key and look back. It's like as bad as it can get. And last year, 9 years after that was announced, there's still 11 million people pulling down that particular version. So there's no good reason. You can't say I'm using Bouncy Castle, but I don't actually care about the data I'm encrypting, because if you didn't, why are you using it, right? This speaks to a massive disconnect between the publishers and the consumers and the knowledge about what's going on inside those components. I think a lot of people have probably heard about Commons collections. This was a vulnerability that was disclosed, I think it was closing on 2 years ago now, which actually wasn't a bug inside of Commons collections. There's a class in there that's sole purpose in Java, sole purpose in life is to instantiate a class and then execute it. Well, somebody figured out how to use that and chain it together with other deserialization types of things to great effect. And this one here, unfortunately, is one of the first ones that we saw be really massively exploited and talked about in the news. I think the San Francisco Bay Area transportation, their systems got hacked through this. This is a picture of Mercy Hospital. They actually got the ransomware installed on their systems. They believe it came through an application or an application server that had Commons collections on it. And this is where it really starts to matter, right? We talk about people stealing our identities and things like that, and that's annoying and bad. But in this instance, this hospital was shut down. There were people in ambulances and people about to go into surgeries that were on their way to this hospital that had to be diverted at the last minute, right? And when you're in an ambulance in a critical situation like that, seconds count. And so you take a whole big hospital offline, and that's a pretty bad scene, right? It's only a matter of time if we don't get our act together before bigger things start to happen in terms of our financial markets and air traffic control and those kinds of things. So if we take a look at the Equifax scenario, which is all the rage lately, this kind of shows something that we had seen in the past. So on March 7th, that was sort of the 0-day line, right? That was when Struts announced they put out a fix to a particular vulnerability. They announced that it was there, and within 2 days, the early indications were that they started getting probing attacks, right? And we've seen this actually with all of the Struts vulnerabilities that I've had visibility into, is that most of the attacks come after the disclosure, right? And that's the point of this talk here, is that the attackers basically have the first mover advantage. And so here, this is a Gartner chart showing how over the past, how far back does that go? Back to 2006, how the time to respond before an exploit has increasingly come down over the last few years. right? And I think this is partially a function of more and more of that open source is being used. You know, if you overlay those charts together and you flip one over, they're gonna match a lot. So I think it's partly that we're using more and more of the open source, and it's partly also that the attackers are starting to figure out this is an easy way to win at this. So if you think like an attacker and you wonder, why is this really happening? Well, before we were building on top of all of these, you know, common components, finding a vulnerability in a particular application is like finding a needle in a haystack. You'd have to sit down and try to break it. This is where things like SQL injection and those types of things, classes of vulnerabilities that you might figure out, come into play. But nowadays, basically what we've built for ourselves is, you know, a shared attack service and what you might call a common mode failure, right? And so it makes that target that much more juicy because you don't have to work quite so hard to get at it. And if you can figure out how to get at it, or if you can figure out how to exploit a particular one of these vulnerabilities, you have potentially tens of thousands, hundreds of thousands of easy targets sitting out there, right? You don't have to pick Equifax and try to break into Equifax. It's possible that they just got picked up by some kind of system doing a scan across the internet, or even just doing a Google search for .do and finding applications that use struts, right? So I'm going to switch here and show how easy this actually is to exploit one of these things. For those of you doing the capture the flag, you probably already know this, but still fun to show. So earlier, you know, I was doing some research on this. So I figured out, well, how can I find a way to exploit this latest struts vulnerability? So at the beginning of September, I think it was, there was a vulnerability release that applied to the struts REST module. So you do a search for Metasploit struts REST, you get a hit, you even get some nice videos that show you how to do it. And so basically the Metasploit stuff has the script code in it. It's a module to the tool, and it comes with shell access and all these types of things. So you don't even have to figure out, like, after I've hacked this application, what do I do with it? Because you just push a button and it'll probably, if it works, get you a shell access, right? So if we look at what actually is being submitted in the application, this particular vulnerability boils down to a deserialization attack. And so the part that I've highlighted here is actually the payload that matters. The rest of it is just decoration around it. And so what happens here, because it's not paying any attention to what classes are being instantiated, it allows us to call this process builder, which is very similar to the class that was in Commons Collections. And so we have this running on a virtual machine here. And so what I've done is we've taken the Struts Showcase application, which is the demo application that just shows a developer, it's sort of the hello world of like how you use all the different aspects of struts. We've stood that up, and we've taken that sample code and put it into a Python script just to make it super easy to demonstrate. And so over here, you know, I'm just watching a particular file. And if I go to this particular window here, you can see I'm calling the Python, I'm passing in the URL, you know, localhost struts2 rest showcase, and then basically I can put anything I want into this particular command, and it's going to be execute. So if I want to find out who this particular thing is running as, I can do so. Let's see what's going on here. The window size is hosing me up. All right. Right, I'm putting it in the wrong file. So let's put this here, and we'll run who am I on this one. So this is where this demonstration starts to show where chaining of particular things start to come into play, right? Because this thing is running as root, right? And so automatically I find out, oh, this is great. I got a bunch of access to these types of things. This application also happens to be running in the default location, which is what I was trying to exploit just a second ago, right? So because I've gone and done my research, if I'm the attacker, I know where struts is installed by default. So if I'm just shooting at this thing, because you know, in this demonstration, I have the privilege of actually opening this window and seeing the results go to the file. But if I was remote, I wouldn't be able to see that. So I have to make some educated guesses about what I'm actually going to try to execute here. And so in this one, you know, if I go to the website and I poke around, this is another common mistake that people make. They don't take the default stuff out of the Tomcat application server, right? So this thing is running on the same port, but in a different context in my application. So I look at this and I could try to go directly at the manager app. But in this case, we've got some static documentation here. So if I want to find out who this is, I just pipe it to a known location where this stuff might be, and then see if I can read that file, right? So same thing. So, in the first example, it was just there to make it easy, but you can start to see how you can chain these things together. And I think Shannon was talking before about, a kill chain, right? There's a couple of places I just showed where a kill chain could have messed this up. First of all, I shouldn't have been running it as root. Second of all, a not default location might have made this a little bit harder, but really for something like Metasploit, not really. Because the way those things tend to be used, there was some other analysis, I thought this was sort of interesting. This particular Imperva, they were looking at where the attacks were coming from. A big chunk of them were coming from China. They think it was probably just an open SSH, it was a compromised machine, and then they were exploiting it everywhere. But this, I think, is pretty typical. These are the commands that have been observed in these types of vulnerabilities being sent. And if you look at them, they're pretty much all attempts to try and go get something else and execute it, right? So in terms of another kill chain type of thing, the system shouldn't be making unexpected outbound requests to curl or wget, or maybe you take curl and wget off of the system or something like that, right? So this is sort of the line of thinking you need to go through when you're trying to build a security in depth type of approach. That it often takes multiple of these things chained together to really get you hosed. And if you take one of them out, your chances are at least better. So the point of all that is to show, how easy this really is. You don't have to be an expert. You don't have to be able to actually win at a capture the flag game. You just need to know how to download Metasploit, run the program, and do a little bit of Googling. And so I think that's why we're seeing, these types of trends back here, where you now have even less time to respond than you used to. And so that's why they have the first mover advantage, because even if you know about this particular vulnerability, if you don't know where in your organization you're actually using it, which applications are actually vulnerable, you don't have a way to even start your remediation plan. So let's talk about that. The way to figure this out and the way to solve this problem is to recognize that this is really a supply chain problem, right? And for me, I think it feels better to know that we're not the first ones that have had this challenge. We don't have to sit down and come up with a solution from the ground up. And so I have these three pictures here because these are three important kind of examples. That one over there on the far left, that's the Chevy Cobalt. And 3-4 years ago, I think it was, there was a massive recall that resulted from, unfortunately, some people dying because there was problems with the ignition switch. And so this is just a classic configuration management mistake. The engineers figured out the problem with the switch, and they fixed it, but they didn't rev the version number. So there were lots of buckets of these switches out there in different factories, and even after the engineers had found and fixed the problem, they were still being installed in new cars. And unfortunately, people died. And then when they went to go do the recall, much like typical companies today, they had no idea which of those cars were actually affected. They had to recall every single one of them because they couldn't tell the difference between the good 1.0 switch and the bad 1.0 switch. The 787 Dreamliner, when it came out, this is a sort of a contrasting example. They had some problems with their batteries catching fire while they were parked at the terminals. And because they did have good practices, they were able to trace it down to a particular manufacturer of the batteries in a particular lot and then go fix them. And so this didn't get as much news. It was a problem only, and it was sensationalized only because the Dreamliner was so over budget and so delayed that everybody was saying, hey, it's a big deal. But in reality, they did a good job of fixing it. And there's always the listeria outbreaks and those types of things. And I think we as consumers have grown to expect that when those things happen, they know how to do a recall. Right? Several years ago, there was, Listeria and Bluebell. That was down here in Austin, right? So you guys might remember that. And the sad situation is that the way we develop our software these days doesn't even allow us to do these things. We as consumers expect the things we consume to have these basic principles, and yet the software we're doing at work doesn't even meet that standard in a shocking amount of the cases. And so, if we compare that back to Detroit in 1982, it was a very similar thing. The focus on the production at that time was on how fast they could get out cars. right? If you're a developer, this might sound familiar. The only thing they were measuring is how quickly you could get it out. They were producing, or they had a quota of 15,000 cars a day. And that's how they were gold, and that's how they were rewarded. And this led to instances where when the supply chain fell apart, that if they had bad parts or they had the wrong part, they would put these things into the car anyway just because their goal was to get cars out. There was no measure around how good those particular things were. And so they basically just decided, we'll keep the assembly line going, we'll ship it out the door, and we'll fix it in post-production, right? And that kind of maps to how we're building our software. And, you contrast that to the Japanese automakers, which after being destroyed in World War II, when they started to be rebuilt, they were working with Edward Deming, who really helped them think differently about this. And this is a good quote from his book there that came out right around the same time, 1982. You cannot inspect quality into a product, right? You can't fix it after the fact. And so this speaks to a lot of application security types of approaches that have scans and things like that come very late at the end of the release process, or maybe just somewhat periodically, once a month, once a quarter, they'll try to do a pen test or something like that. That's the equivalent of expecting that just because we do inspections of our cars that we're going to catch all of these problems that trace back to bad components going into them. And so the best organizations that we've seen are thinking about this problem, like I said, like a supply chain, and starting to do very similar things. So using fewer and better component suppliers, right? So this starts to speak towards thinking a little bit more carefully about your application portfolio and the architecture that goes into it, so that you don't expose yourself to every single possible web framework that's out there and all the vulnerabilities that come with all of them. If you can scope it down to a couple of good examples, like use Spring, not struts, or something like that, you can reduce that surface area. You get other types of innovation gains because your developers tend to become more portable when you're using consistent types of software across your portfolio. Much like we expect our cars to have only the best parts in them, make sure that within the suppliers you're using the right versions of those particular components. So you need to be able to be set up to be keeping up to date on those particular versions, because we know that software is never going to be bug-free. There will be bugs. Some of those bugs will lead to vulnerabilities. You need to be able to respond to that. And if you're sitting here today and you're still using Struts 1, well, not only have you been completely hackable for like 10 plus years at this point, but getting to a version that's not exploitable is almost impossible, because you're now using such an old version that there's no easy path forward. Right? So a lot of people will tend to find components, they forget about what versions they're using because it works. If it's not broken, don't fix it. But these things are rotting away at the architecture. And then when, not if, something happens, you're not set up to be able to respond. And all of these things lead to that widening gap. Remember, the attackers are watching the vulnerability disclosures. They get to work as soon as this comes out. The Metasploit comes out within days. And if you're stuck on some old version and you need months to remediate it, what are you going to do? So this comes from the first way of the Phoenix project, emphasize performance of the entire system and never pass a defect downstream. Right? So it's exactly like the auto manufacturers. We shouldn't set ourselves up so that we're only trying to push stuff out and we have to do kind of dumb things. We need to be able to hit that big red button or pull the cord to stop the assembly line and make sure that we fix these things. So the reality of how software development has changed certainly over my career, is that in the early days it looked like this, right? You had a very traditional waterfall life cycle where you had the RUP processes and stuff like that, and you had a lot of time between each of these different phases to inspect, make changes, and adapt. Well, 15, 20 years ago, we started thinking about Agile and Scrum and stuff like that. And so what that really happened was it focused on this middle part of the software development and the software testing to make them a little bit more iterative with sprints and things like that. But it really didn't focus a lot on the deployment and the operations aspect of that. So even though we were going really fast and iterating quickly within the development process itself, we still had some time after a release before it got out into production. Well, nowadays, where we have basically continuous everything, it's quite literally possible that I commit some code and within minutes that code is running on my server, right? This is how the unicorns, Netflix, Facebook, all those guys work. And everybody's sort of trying to move in that direction. So if you're not there now, you probably will be soon. And so the ramifications of that are quite profound. If I'm picking up and using the bad version of a new component, I throw it in there, there's no time for somebody to be able to catch that happened, right? And if you were trying to do any type of manual inspection or manual process, these numbers just make it impossible. Where you used to have 1 or 2 releases that you'd have to deal with a year, now you potentially have hundreds a day, or thousands a day even. And so from a governance perspective, both from a legal, licensing type of thing, as well as from a security and architecture perspective, we've kind of painted ourselves into a corner that all of these manual approaches, all of these post-build inspections, much like the autos of the 80s, it's not going to work. And so what that means is you really have to figure out how to automate that approach. How do you build the security into this? How do you understand what's really important? And for me, a lot of this is like when we started doing continuous integration. Prior to that, we had a few people, humans usually, with running down some, I forget what they're called now, the sheets of like push this button, type this thing in, right? And those things would rot away over time. It wasn't until we actually built into the system automated integration tests, automated unit tests, that we were really able to code in the types of quality that we wanted. We have to think about that from a security perspective, specifically around how we pick better components that make up that 80% of our application. And so, there's a couple of key ways to do this, but this is how I tend to think about the problem. The first part is early awareness, right? You need to be able to build a process and automate it in such a way that your developers, who are on the front lines, whether you want them to be or not, have the information of what's going on, right? So, much like the auto workers who are putting bad parts on, developers often are gold for speed and those types of things, but they're not paying attention to these. They don't have easy access to the vulnerability information. And so you need to really figure out, how do I get that information in their hands? Because it's not going to work when you have only an application security team who's off on a silo looking at these vulnerabilities and then trying to prove to development that it happens. We see a lot of cases where there's a very hostile environment between those two ecosystems, or between those two siloed organizations, and there doesn't have to be. So you need to be able to give the information to those developers, and you need to empower them to be able to make those changes. We see a lot of organizations that have open source policies in place, right? We have a survey, some of those slides come from the state of software supply chain. Only 6 in 10 have open source policies around what cannot go into an organization. So that means 4 out of 10 aren't even paying attention to what's going on at all. The problem that I see a lot is that the 6 in 10 who are paying attention have done so in a very, very draconian process that basically slows down innovation by prohibiting developers from picking up new versions. And so, if you need to pick up a new version because it's got a new feature or because it potentially has a security vulnerability, but you have to wait weeks for some dude in the corner to go, do who knows what kind of check and put it on a blessed list, it's just not going to work. That's further incenting this risk that I was talking about before, where you start using older and older components and then it's impossible to update, right? So even if you have a process, you got to make sure that it's working with development and not working against them. And you need to be able to integrate everywhere across the life cycle. Just like the supply chain, when parts are coming in, you need to make sure that they're good before you accept them from the vendor. The people who are installing them on the cars need to be checking to make sure that everything's lined up before they bolt it in. And so from development perspective, it's the same thing. And I'm going to show some pictures of how that works in real life in a minute. But you also need to be continuously monitoring these things, because we know that applications, we know that software has bugs in it, and our understanding of them changes over time, even if we haven't touched the code. So you need to be constantly looking for these types of things. And so, I like these sets of slides here because I think it helps put how modern development is happening in context. It all starts with the developers at the bottom, right? They're writing the code, checking it out from source control. Increasingly, developers are using some modern build system. It's not just Java, but it could be NuGet. On the Microsoft side, it could be PyPy, Composer for PHP, right? All of these things are able to reuse as building blocks other pieces of code, whether they're source code or binaries. And what that tends to happen is when they're doing development, those things are just fetched from a repository. If your organization is paying attention, they probably have an on-premise repository for those things, which is proxying them from the public. Developers will check the code in, and then the CI is basically repeating that same process, right? This is hopefully not news for anybody here. What then happens, though, increasingly, is those things are now getting automated out into deployment. In some, if you're running services as opposed to shipping software, usually you've got some instrumentation that's actually making that happen. And so on the left here, this is what we've been talking about for years with continuous integration, right? We're thinking just fundamentally about when a developer writes some code, I want to check it in, I want it to automatically build and run the tests. But the more modern stuff now is actually taking that and pushing it right into production. And so when your developers are sitting there trying to pick a new component, trying to pick a better version, this is the best place to be able to surface that type of information. You need to be able to have them understand that the thing I'm about to put into the code is actually bad, right? They don't have the tools, in most cases, to inspect these third-party components. But the tools are out there. They can be done. But unfortunately, a lot of organizations, for whatever reason, are afraid of their developers, and so they hold these lists off in the secret, and so the security teams are off and they got these lists of things, meanwhile developers are baking new versions in when it could be very simple for them to be able to make the change. The inverse is often also the case, that organizations will often come out with an edict that like everybody must stop using this component or this version of the component and move to this other one. And that's really problematic because that just doesn't take into account the actual information that the developers on that application have around the particular context. It may be that a particular vulnerability doesn't even affect this. It may be that moving from one version to another is seriously risky, right? And so we try to look at this and say, can we at least all have the same basic sets of information, security guys and developers, so we can have a rational conversation about this? For example, our testing of this particular component is not good enough. I don't feel comfortable moving, especially if there have been API changes. Is there something else we can do to remediate this in the short term, right? The security team might be able to help with a WAF or something else to at least get you over that hump so that you're not completely vulnerable. And so what tends to happen with those global edicts is they'll come out and then the teams push back and say, okay, but now you've just made our application late. And ultimately, these things all lead to somebody signing a waiver somewhere that says, yeah, I accept some unknowable business risk. And because we're all still focused very much on the bottom line of trying to get things out the door. So that's the first part. The other part is, if you're using an application and you're pulling these things in from the internet, from repositories like the one we have and others, it doesn't make sense to even allow those things to come in the door if at the time you're pulling them in, they're known to be vulnerable, right? Think back to the bouncy castle thing that I gave you. Everybody's still pulling that 11 million times 9 years later, right? If they just stop that, it's not going to help the stuff that's already baked in, but it will at least stop it from matriculating across the organization and continuing to spread into new applications. So that's another way that you can bake this stuff in and really think about how you can control the flow there. From my perspective, the most important place, however, is to be able to do it in the build. Like I was talking about before, I like to think about the policy controls from a governance, security, legal perspective, just like the unit tests. And this is the place to do it. And so if you're able to do automation against what's in the application, because the other thing is if you're at development time, you may not have a full view into what's actually being packaged into the application. They might only be working on one part. But at the CI, you have the context of the application that's being built. You'd know if it has a database, so if there's SQL injection, if there's no database, those things are out of scope, right? You know if it's a public-facing web application. You know if it's dealing with PCI because you know what application you're dealing with. So you can have very nuanced policy controls that make sense for this particular application. Because the most important thing that you want to deal with is you don't want to be setting off all kinds of false positive alarms because basically when you get to that point, everybody's just going to ignore it, right? It's like the car alarm that's going off in the neighborhood all night long. So you need to be able to do some assessment at the build time so that you have that context, and it solves a lot of these problems. When you've automated all of these things, your repository can then become a trusted set of components. But don't confuse this with what people call a golden repository. What we've seen a lot of times is that organizations try to solve these problems in a very manual way by having some dude in the corner, again, checking out a component, and then when he gives it a thumbs up, he puts it in that repository. And so at that point, everybody thinks about this is a repository of golden components, the golden repository, the blessed standard. Well, that may be true if he did a good job when he put them in there, but I've never seen anybody who's actually continuously looking at those things to uncover when the components are no longer good. I guarantee you in organizations using struts, there are still vulnerable versions of struts in that repository. And so the way you need to think about that is what you're basically saying is something is good merely because it's in this box. That clearly doesn't make any sense, and yet that's what a lot of organizations are doing. And so in order to make this work properly, again, you have to be able to code those policies in a way that's automatable and automatable to the point where it can take an automated action. Not just automation as in go do a scan and kick out a report for somebody to ignore, but automation that can actually stop one of these builds or stop a deployment, right? And that's the next phase, to be able to look at the policy enforcement at deployment time. Right? You need to be able to be looking all the way across the life cycle, much like modern development or modern automakers are doing, that there's these checks all the way across the board. Because you might have built something into an application and maybe it's just a submodule and it happened a month or two ago, and so the policy was good at that time and it went into the repository. And now, at some point later, you're actually about to roll the whole application out. You probably should do a double check and make sure that at that time it's still good, because it might not be, right? Being able to set it up this way also has another less obvious benefit. It's really obvious to me as a developer, but this allows you to be a little bit more nuanced in how you actually approach hitting the developers with a hammer, right? We see a lot of instances where people will set up these rules and they'll try to do the blocking or breaking of the build, but because they've only integrated into one place in the life cycle, let's say the CI build, it basically means that's the only place you can put any control. It means the only place you can break a build and stop it. And so the unintended side effects of that are, if you had a process that was able to enforce the breakage of a build on a new vulnerability, and everything was fine yesterday, developers go home, vulnerability hits the wires overnight, they come in the morning, all the builds are broken, right? In some cases, let's say you have to swap out a component, a good process would probably be, well, let's check out the last tag, let's build it, make sure all the integration tests pass, so I'm good there before I start monkeying with stuff. Well, what if that thing is interfering with my ability to actually build that, right? I've just accidentally made it harder for developers to actually fix the very problem that I'm trying to incent them to fix. And so what we like to educate people to do is when they're thinking about it this way, mark the build as unstable or something, which is basically what's going to happen when unit tests fail. And this is a normal thing for developers to deal with every day. You get the email. We were talking last night, somebody said the only time I hear from Jenkins is when I did something wrong, right? If I get the email from Jenkins, I know someone's going to yell at me. The build itself didn't have to be blown up to get action on the developers, because we've put it now in their context. But from a policy perspective, if I'm the ops guy, I might be concerned that somebody accidentally ignores that thing, and so I want to put the brakes on the whole process. That's where, if you have the integration later, you can do so. So it allows you to be a little bit less harsh in the development environment, assume that they're going to do the right thing, they've got the information, early feedback to make the changes, but you can sleep well that nobody's going to accidentally deploy something and ignore it because you're doing policy checks at the deployment time, right? And so as we start automating more and more of our continuous delivery and our deployment, this stuff actually becomes a whole lot easier. We don't have to worry about some guy picking up a war from a repository and throwing it on a server and forgetting to do the check, because that part is all automated. So if you're going to automate your policies in the CI, why not automate them at deployment time? And then lastly, you need a process to be able to monitor the things that you've shipped for new issues. Because like I said before, our knowledge about what's actually in these things increases over time. We find vulnerabilities in old components all the time. None of the vulnerabilities we talk about are knowingly released by these open source projects, so by definition they all come later. But if you've shipped it, or if you've got a legacy application that you're not delivering, not building anymore, if it's not going through this process, but it's still out there running, you need to pay attention to that, right? And so from some of our studies that we've done, looking at customers that have done this and paid better attention to it, we could see some really good improvements. So on the far left, that's the 5.5% of downloads we were talking about before. Those are vulnerable. Inside the the repository, we're finding a higher percentage of the components in there are vulnerable. That's not really surprising because these repositories tend to have even versions that aren't currently used, so you have a accumulating effect going on there. But it's this last part that's really interesting. In organizations where they are understanding that this is a supply chain and doing something to manage it, their applications have only 1.7% vulnerabilities versus 4.6. It's a 69% or 63% improvement, right? So just being aware and starting to think about this stuff will start to have some pretty transformative effects. The 1.7%, we can't obviously know why those are in there. Clearly, if they've been managing their supply chain, they've been paying attention. My guess is these are probably things that were remediated by other things. They had some compensating mechanism in the kill chain for that, and so they made a rational decision to, let's go ahead and keep shipping this for now because it's too disruptive to change it, but we've at least, because we're aware of it, closed the door. Because I can't think that people would just willingly ship stuff after they've shown that they can do a good job, that they're going to ignore it. So these numbers just come from our ability to look at these applications across this wide swath, but we can't tell what they're doing. So anyway, point being, if you pay attention to your supply chains, you can get pretty good improvements. And it's pretty impressive when you put this into context in larger organizations, right? 48% increase in application quality. We had one large customer who was able to completely automate all of the manual process, the inspection, all of the gear mashing organizationally that was going on between security and legal and operations and the developers, and they saved 34,000 man hours in 90 days, just 90 days, right? So if you think about all the time being wasted trying to manually track this stuff down, and then think about the fact of how ineffective it is, it's kind of a no-brainer. And so bringing it back to Equifax, I feel like the Equifax attack, because it basically affects everybody here, like, what is it? The number keeps going up, 145 million Americans, something like that. I think that's maybe our Ralph Nader moment, the inflection time where people really start to pay attention to this. For those that don't know, Ralph Nader had this book, Unsafe at Any Speed. I think it was the Pinto back in the day, but really made made the public aware of how bad the auto industry was at doing things, and that basically they were making this judgment call of, well, it's we can afford to pay for X number of people that die. It's still cheaper for us to continue doing what we're doing than change. And so, this is a quote from the UK's National Cybersecurity paper. But software liability is sort of one of these things. It's inevitable, right? Lots of people have been talking about it. Josh Corman's been talking about it. I think the inevitable outcome of us as an industry ignoring best practices that are obvious on their face is that we're going to get some type of legislation crammed down our throat. And so it doesn't matter if you're Equifax, obviously, that the vulnerability was in Struts, because it was really in their application. And their application and their databases had our data in it, right? And so we can't shirk the responsibility by saying, well, it wasn't our code, it was third-party code. And so you really need to be thinking about how you're going to deal with that, because it's going to happen, right? So if the benefits on this slide aren't enough for you, for some companies, they're going to get forced to do it. And I think in the end, we'll probably all be better for it, but it's going to be bumpy as we go through it. So getting close to the end of time here. If you're interested in more of these slides, a little bit more in-depth analysis, we have a software supply chain, and I know a lot of you here probably saw the all-day DevOps stuff. There was a watching party yesterday. One of my colleagues, Derek Weeks, he had some of the same slides, did a really in-depth analysis of some of this stuff. So if you go search out all-day DevOps, you can find some more information on this. But that's the end. Any questions? No questions? All right. Go capture some flags then. Thanks for coming.